Welcome to prelab number 4. If you're wondering where I'm doing these, this is in my living room, so I'm sitting here on my couch right now. So this is coming from my home to yours, perhaps. So this is our lab number 4 prelab, and we're going to use methods to determine density. We already did a lab on density, but we're going to use a little bit more experimental technique for these. Ooh, that just makes me cold looking at that. I actually saw this earlier. I was in Alaska. That was nice. God, I saw the aurora borealis. Really, really beautiful. Really, really beautiful. Okay. So, density. Oh yeah, it talks about water. Well, water freezes. The most common form of ice, alpha ice, does float on water. But I won't bore you with this stuff. That's what you have a lecture for. So let's go into the lab. So here are materials. So the first part of the lab should be fairly easy. The second part, there's room for things. And when you do this, just be honest. Like if things go wrong, I'm not surprised if it's going to go wrong. I mean, you're doing this at home, and I would have a hard time doing this in the laboratory because you'll see later the stuff is mixable. So just be honest and tell me what you see and observe. That's more important than making stuff up. Okay, so just. And that's also a lesson for you. There's a bit of error in science. So we've already talked about density, so you know about density. Oh yeah, we should talk about to weigh this out. So take washers. So the idea, we're going to figure out how much the washers weigh, or as my father would say, the warshers. So let's weigh out 10 warshers and see what their mass is. So weigh out, get 10 washers. Sorry, I'll do the proper. Take 10 washers and record their mass, and then take a 50 milliliter graduated cylinder, or 100 milliliters, and fill it up to the 50 mil mark, as close as it doesn't have to be 50 mils. It has to be something you can measure the difference in volume. So we're doing the amount of volume that the washers are taking up by water displacement. So if it's at 50 and then you put the washers in, it's 53.5. That means that the washers have a volume of 3.5 milliliters. So the important thing is you have to know how much difference there is in that. So that's what you're going for. So you have the mass, you have the volume, you get the density. So then once you have the density, then you use this to figure out which one it is. And just make your best guess. You can see here copper and nickel are pretty close. Of course, copper is red and nickel is silver colored like everything else. So, use your best. If you get between steel and zinc, the washers, truth be told, they're probably going to be zinc. And if you get red washers, you know right away they're copper. But everything else here, lead. Lead is going to feel heavy. It's going to look kind of darker. It's going to have a dull color. Aluminum's, truth be told, I can tell what material thing is a lot of times by the grain pattern. Aluminum and zinc. Aluminum has a sort of white sort of color if you look really close to it, and zinc has this kind of web sort of color to it. We're not going to send you silver washers. Come on. Silver costs too much money, so it's not going to be silver. But anyways, so it's probably going to be steel or zinc, and of these two, most likely zinc. So. But try it out, see what you do. So now, anyways, let's look at the density of plastics. So you take your beaker. Of course, the beaker. This is shown as a glass beaker. You're going to have the plastic beakers in your kit. Now, so put 10 milliliters of 1 molar calcium chloride on the bottom. This stuff is really safe. You probably can drink it if you want to. I'm not telling you to drink it. It's a bad idea. You never drink anything that comes in your lab kit. Remember that. Safety. But this stuff's pretty darn safe. Water. Let's put in the water. Now, ethanol, water, and calcium chloride, these are all miscible, so you can mix them. So try and be as careful. Do it slowly as you can as to not mix them. And do this, so pour it slowly. But do the lab fast, because these are going to mix. There's a mix, and then put the ethanol on top. And the ethanol is going to be denatured. So don't drink the ethanol, okay? Do not drink this stuff. I know that ethanol is the alcohol that's used in things like beer, but they are going to put a bitrix in it, which is going to taste terrible. And it might even make you throw up. So don't drink the ethanol. Ugh. Anyways, now that you've had that public service announcement, put the pieces of plastic on there. Little hint, don't let any air bubble get trapped underneath that, because if you get air bubbles, they're going to float on top of the ethanol. So you might have to take your stirring rod and poke them a little bit if air gets trapped under there. If it's floating on top of ethanol, you know, poke it a little bit, and then I mean, if you keep on doing that and nothing happens, then then it's going to be lighter than ethanol, or less dense. I'm sorry, I should say less dense. This goes by density. If it sinks all the way down, that means that the density is greater than 1.1 gram per milliliter. If it goes to the bottom of water here, it means that it's between 1 gram per cubic centimeter and less than 1.1 gram per cubic centimeter. If it's here in the ethanol has 0.8 grams per cc. That means that it's more dense than 0.8, but less dense than 1. And if it floats on top of the ethanol, that means it's less dense than 0.8. That's what that tells you. So do it kind of quickly. It says to look at it a little bit. But at the same time, this stuff will mix. And don't take your stirring rod and mix it, because then you're going to make a mixture, a uniform mixture. So remember, the key to this lab is to pour the liquid slowly, but to do the measurements quickly. But do it as best as you can. I know that you only have a shot or two at this, and if it doesn't work out, you can just tell me what you see. So, but it's kind of cool at the same time, because then you can see things floating on different levels. So, but good luck, and let me know how it all turns out. And I want you to take a picture of your plastics here in the beaker.